In this video,
We'll break down how batteries work so that you can understand what's powering your phone, why batteries die, and how to use rechargeable batteries more safely.
let's get into it.
What's actually inside a battery? A battery isn't a tiny box filled with electricity. It stores chemical potential energy, meaning energy held in the arrangement of its materials. Inside there are two electrodes, an anode and a cathode. During discharge, the anode releases electrons through a reaction called oxidation, while the cathode accepts electrons through reduction. Between them is an electrolyte, which carries electrically charged particles called ions. There's also a separator that keeps the electrodes from touching while still allowing ions through. Without that separator, you could get a short circuit and a very spicy little battery. But here's the key. Electrons and ions take completely different paths. How does a battery produce electricity? When the battery isn't connected, there's voltage between its terminals, but no sustained current. Voltage is the electrical potential that pushes charge. Connect the battery to a complete circuit, and electrons leave the negative terminal, travel through your device, and reach the positive terminal. Along the way, they transfer energy to a light, motor, speaker, processor, or whatever else you're powering. Meanwhile, ions move through the electrolyte inside the battery to keep its electrical charge balanced. So electrons travel outside while ions travel inside. Both movements are essential. Next, this explains why some batteries can recharge and others can't.
By the way, if you're getting value out of this video, hit like, subscribe, and tap the notification bell to get more valuable content like this.
How do rechargeable batteries work? A charger applies an external voltage that pushes electrons and ions back toward their higher energy arrangement, reversing much of the discharge chemistry. In a lithium-ion battery, lithium ions move between two electrode materials. During discharge, they move toward the positive electrode, while electrons power your device through the external circuit. During charging, the charger pushes them back. Single-use batteries use reactions that aren't designed to reverse reliably. Trying to recharge them can cause leaks, overheating, or pressure buildup. So yeah, the charger drawer isn't the place for chemistry experiments. Why do batteries lose capacity over time? Charging isn't perfectly reversible. Tiny side reactions gradually consume useful material, damage electrode structures, and increase internal resistance, the opposition to current inside the battery. Heat speeds up many of these aging reactions. Cold, meanwhile, slows ion movement, temporarily reducing performance. That's why your phone battery can act dramatically in winter, then recover once it warms up. Fast charging can also create more heat and stress, especially near full charge. A battery management system, or BMS, helps control voltage, current, temperature, and cell balance. What do battery ratings mean? Volts measure electrical potential. Amps measure current, or how quickly charge flows. Amp hours measure charge capacity, while watt hours estimate actual stored energy by multiplying voltage by amp hours. So a battery can have lots of energy but deliver it slowly, or provide a powerful burst without lasting long. That's why a clock, power tool, and electric car need very different battery design. Ultimately, understanding batteries helps you compare products, interpret capacity claims, protect battery lifespan, and recognize warning signs like swelling, extreme heat, or physical damage. A battery isn't storing loose electricity. It's running a controlled chemical reaction that sends electrons where you need them.
If this video helped, leave a comment below. If you want to keep learning, check out this video next. Thanks for watching, and I'll see you in the next video.